Welcome to this computer-based training module. The module is designed to introduce you to the basics of anti-lock brake system. The list shows the course objectives and the topics covered in this module. During a normal or sudden braking, wheels tend to lock up on loose, wet and slippery surfaces such as gravel, water, ice, etc. This may result in loss of traction and steering control, causing the vehicle to skid or spin. Anti-lock brake system avoids locking up of wheels during braking. This helps to maintain directional control and avoid hazards if you can't stop in time. Car with ABS stops quickly and is stable on all surfaces. ABS comes to rescue when driver has to brake and steer around an unexpected obstacle, for example, an animal on the road. The illustration describes the benefit of ABS when car ahead of you stops abruptly. ABS avoids locking up of wheels by automatically changing the brake fluid pressure. This is done with the help of electronic control unit and sensor at each wheel. When ABS is activated, you may experience a slight vibration or pulsation of the brake pedal. This means that ABS is working. Continue to apply firm pressure and steer without lifting foot off the brake pedal. The function of EBD is to balance and optimize brake force to front and rear set of wheels as per load, speed, and type of vehicle. This is achieved by reducing brake force to either front or rear set of wheels. EBD helps in achieving controlled braking in all conditions, whether you're driving alone or carrying a full load of people or luggage. EBD system comes as add-on feature of ABS. The illustration describes the layout and parts used in a typical ABS system. Wheel speed sensor has two parts: sensor ring and sensor. Sensor is generally installed on knuckles in the front and axle housings in the rear. The sensor ring is generally installed on drive shaft in the front and the brake drum in the rear. When the sensor ring rotates, the magnetic flux from the permanent magnet in the wheel speed sensor changes. This generates alternating current voltage in the coil. Based on the frequency of this alternating current, the speed of each wheel can be detected. The hydraulic unit is installed between the master cylinder and the wheel cylinders. The hydraulic unit contains two parts: ABS controller and the hydraulic control mechanism. ABS controller receives the signals from wheel speed sensors and gives control command to hydraulic control mechanism. Hydraulic control mechanism contains solenoid valves, reservoirs, pumps and pump motor. On receiving the control command, it actuates the solenoid valves and controls the hydraulic pressure to each wheel cylinder. Stop lamp switch gives signal about depression of brake pedal to ABS controller. In case of defective stop lamp, ABS will still work, but there will be slight delay in its operation. In case of any malfunction in the system, the ABS and EBD warning lamps turn on to alert the driver. Let us examine the working of ABS system. Use the buttons given at the bottom of the screen to explore the working of ABS system. When ignition switch is turned on, ABS warning light and EBD warning light turn on, for about 2 seconds to check the operation of the lights, and then they turn off. ABS uses 4 wheel speed sensors to detect condition of each wheel. The ABS controller, which is part of hydraulic unit, detects the wheel locking conditions by signals from the wheel speed sensors. After receiving signal, it then sends a control command to the hydraulic unit. After receiving control command, the hydraulic unit operates the solenoid valves to alter the brake fluid pressure to each wheel. During normal braking condition, all the wheels slow down together, and all the wheel speed sensors give signal of almost equal frequency to the ABS controller. In such conditions, the ABS system does not get activated and vehicle stops normally. However, in sudden braking situations, it is possible to get the wheels locked or stopped due to various reasons, such as slippery or loose surface. The ABS controller detects the wheel locking conditions using signals of wheel speed sensors. Then the controller gives command to hydraulic control mechanism to reduce pressure to the wheels, which have locked. The hydraulic control mechanism repeatedly reduces and increases the brake pressure to the locked wheels. This helps driver to retain the direction control on the vehicle as well as stop the vehicle safely. ABS control module has an onboard diagnosis system which detects a malfunction in the system. When ignition switch is turned on, ABS warning light and EBD warning light turn on for about 2 seconds to check the operation of the lights, and then they turn off. When ABS control module detects a malfunction in anti-lock brake system, it turns on ABS warning light and EBD warning light and stores malfunction DTC in its memory. It is possible to communicate with ABS control module through data link connector by using Suzuki Diagnostic Tool. Diagnostic information can be checked and erased by using Suzuki Diagnostic Tool. When diagnosing a trouble in the system, refer to the service manual to have full understanding of the outline of onboard diagnostic system description and each item in Precautions in Diagnosing Troubles. Execute diagnosis according to instructions to obtain correct results.
Thank you for watching this video. If you like this video, please like, share and subscribe. Thank you all.